Hello and welcome to today's lecture of Object-Oriented Programming using Java with the paper code CS504A. Myself Shayani Chandro, Assistant Professor of Department of Computer Science and Engineering of Guru Nanak Institute of Technology. So let's look at today's contents of the slides. So today we will be learning relationships among objects and classes, a brief overview of links and meta class, then a recap of class and object, then difference between object-oriented programming and other conventional programming, and lastly, difference between C, C++, and Java. So let us go to the first topic of today's lecture, that is relationships among objects and classes. In the slide, you can see the relationships are written. So let's learn each of the relationships one by one with an example. So here an example is written. We can see that there are 5 points in the example. So let's deal with the first point. The first point says that manager is an employee of XYZ Limited Corporation. So what does this actually mean? We can see that if we look at this requirement, that manager is an employee of XYZ Limited Corporation, then it's a parent-child relationship. Or we can say that it is an inheritance relationship. Now, this sentence specifies that manager is a type of employee. In other words, we can say that we can have two classes, parent class employee and a child class manager, which will inherit from the employee class. So let's look at it. So here we have two classes actually, the employee class and the manager class. Now we can say that manager is a special type of employee. That means this manager class has been derived from this employee class, because a manager is also an employee of that organization. So the manager will also have all the properties of the employee class. So we can say that manager inherits the properties of the employee class. So if we consider it in that sense, that means employee is the parent class, whereas manager is the child class. Now, if I look from top to bottom, we can say that employee is a more generalized form, whereas manager is a more specialized form of the employee class. So if we come from top to bottom, that means we are indicating the specialization relationship. Because if we come from top to bottom, where employee is a more generalized form, but manager is a more specialized form of the employee class. So if we look from top to bottom, we can say that it is a specialization relationship. Again, if we look from bottom to top, we can say that here manager is a more specialized version of the employee class, whereas employee is a more generalized version of the manager class. That means if we look from bottom to top, we can say that it is a generalization relationship. So if we consider this inheritance relationship in between these two classes, employee and manager, there are two types of relationships. One is generalization and another one is specialization. Generalization happens when we look from bottom to top, where the more specialized version goes into the more generalized form, and if we look from top to bottom, the more generalized version goes to the more specialized form. So this is specialization and this is generalization. This inheritance relationship is also known as is-a relationship. Now, why is it called is-a relationship? Because we can say that manager is an employee of the organization. Manager is an employee of the organization. That's why this inheritance relationship is also known as is a relationship. So let's go to the next one. The next point says that manager uses a swipe card to enter into XYZ premises. So this is the requirement 2 or point 2. This is an interesting requirement. In this requirement, the manager object and the swipe card object, both the objects use each other, but they have their own object lifetime. In other words, we can say that they can exist without each other, but both of them are using each other. The most important point in this relationship is that there is no single owner. That means if the manager object is not there, the swipe card object will still be there, and the vice versa is also true. If the swipe card object is not there, the manager object will still be there. That means both are using each other, but both have their own lifetime. There is no ownership. So we can say that association allows one object instance to cause another one to perform an action on its behalf. Association is a relationship where all the objects have their own life cycle. That means there is no owner. So let's take another example of this association relationship. So this relationship is also known as using relationship. This association relationship can be thought of as a using relationship. Let's see how. Suppose we have taken another example of teacher and student. We can say that multiple students are associated with a single teacher, because when a teacher teaches, then he or she teaches to the whole class. That means a single teacher is being associated with multiple students. Similarly, a single student can also be associated with multiple teachers, because a single student has to learn all the subjects that are there in his or her course, and all the subjects are being taught by different teachers. That means a single student has to be associated with multiple teachers. That means both of them are using each other, but both have their own life cycle. If the teacher object gets deleted, the student object will still be there, and the vice versa is also true. This type of relationship is known as association relationship or using relationship, because both the objects are using each other. That's why this relationship is known as using relationship or association relationship, where both the objects will use each other, but both will have their own life cycle and there will be no ownership. Let's move on to the next point. The next point says that manager has workers who work under him. So this requirement denotes that same type of relationship like association is also there, but there is a little difference. So in association relationship, we have learned that there should be one object being used by another object, but there should not be any ownership. This is also same. The manager object is using the workers object, and the workers object are being used by the manager object. That means this relationship is also a little bit same like association relationship, but there is a difference that one of them is owner. Why? Because a particular set of workers will always work under a particular departmental manager. A particular set of workers can never work under a different departmental manager. That means the manager object owns the set of workers object which work under him or her. So let's look at some other examples. So let's take an example of department and teacher. A single teacher can belong to multiple departments, but if we delete the department, the teacher object will not be destroyed. But we can think that there is a ownership kind of thing, because a single teacher is always associated with one or some departments. That means all those departments are all, or if it is only one department, that particular department owns the teacher. If the department gets deleted, the teacher object will not get deleted, and the vice versa is also true. That means there is ownership, but there are the life cycles of the objects which will exist independent of each other. That means even if there are ownership, the objects can still exist on their own. That means they have their own life cycle, but there is ownership. This type of relationship is a specialized form of association relationship, which is known as aggregation relationship. This relationship is known as aggregation relationship, where we can say that a teacher from CSE department and a teacher of electrical department can never be same. That means a teacher who works for CSE department will never work for electrical department. Similarly, a teacher who works for electrical department will never work for CSE department, because that particular teacher has been recruited for these departments. So the teacher who is recruited for CSE department will always be the teacher of this department. Similarly, a teacher who has been recruited for electrical department will always be the teacher of this department. That means this department actually owns the teacher, but they also have their own life cycles. That means both the objects have their own life cycle, but there is a ownership kind of thing. This kind of relationship is a special form of association relationship with ownership, which is known as aggregation. This aggregation relationship is also known as has-a relationship. Now let's move on to the last 2 points. The last two requirements say that manager has the responsibility of ensuring that the project is successful, and manager's salary will be judged based on the project success. That means we can conclude that manager and the project, both the objects are dependent on each other. That means the lifetimes of both the objects are same. In other words, we can say that the project will not be successful if the manager is not good, and the manager will not get good increments if the project has some issues. That means both the objects are completely dependent on each other. If one object is not there, the another will also not be there. As here we can see that if the manager object is not good, that means the project success object will also not be there. Similarly, if the project has some issues, or if the project object is not there, manager will not get good increments. That means one object is completely dependent on another object. If one object gets deleted, another object will also get deleted. This relationship is known as composition relationship. Let's take some other examples. Suppose a house can contain multiple rooms. We know that there is no independent life of room, and any room cannot belong to two different houses. And if I delete the house, the rooms will automatically get destroyed. That means the relationship between rooms and house can be called as a composition relationship. If we delete the house, or if the house object gets deleted, the rooms object will also get deleted. And a room object is completely dependent on a particular house. A single room cannot belong to two different houses. That means this is a composition relationship. Composition relationship is also known as death relationship, because one object gets deleted if the other one is not there. That's why this relationship is known as death relationship also. So these are all about relationships among objects and classes. The first two relationships that we have learned are generalization and specialization. These two are relationships among classes, and the rest three are relationships among objects. So now let's move on to the next slide. So now we will be discussing about object and class again. We have already discussed about object and class elaborately in previous lecture. So in this lecture also we will give some idea about object and class. So this is basically a recap of the same concept. Here we can see that there is a student class. So in this student class there are some properties mentioned. The name of the class is student, and the properties of the class is are name, age, color, sex. So these are the properties of the student class, and these are the behaviors of a student class. That means eating, drinking, running, etc. Now if we look to the right hand side of this slide, we will find that these are the student class objects. So this is the class actually. These are the properties or attributes of the class, and these are the behaviors of the class, and all these objects will have all the properties that are mentioned here of this class student. Like we can see that the first one the is an object of the student class, and his name is Peter, age is 3, color white, sex is male. That means these are the features that this student object has. Similarly, these are the properties or behaviors that this student object can show. Peter can eat more foods, Peter can drink more water, Peter can run fast. That means these behaviors, eating, drinking, and running, are also there in the student object. So we can say that this one is an object of the student class. Let's go to the next one. This is another object of the student class. Why? Because his name is John, age is 4, color is brown, and sex is male. So these are the properties of the student class that are also there in this object. Similarly, John can eat less foods, John can drink more water, John can run slow. That means these are the behaviors that are also there in this object. So this is also an student object. Next, let's move on to the next object. Name is Julia, age is 2, color is white, sex is female. So these are the properties or attributes of the class student that are also there in this object. Similarly, Julia can eat less foods, Julia can drink less water, Julia can run fast. That means these are the behaviors that this object also has. So we can say that this is also an object of the student class. So this is a class itself, and all these are objects of the student class. So let's take some other examples to explain this more clearly. So let us take a pen as an object. So I have already told in the last class that an object can have these characteristics. Now let's see how this pen object has these characteristics. Now we all know that the state of the object is specified in terms of the attributes or properties of the object. The most important property of the pen is to write. So this property describes the behavior of the pen. So the behavior of the pen object can be stated as to write. So if it is a pen object, so its behavior would be to write. Now we have also known that an object's behavior is governed by its state. That means when a pen is closed, it cannot be used for writing. That means we can say that there are two states of a pen. That is, the pen is open, or the pen lid is open, and the pen's lid is closed. So when the pen's lid is open, or the pen's cap is open, the pen can be used for writing. That means in the open state, the behavior of the pen object is to write. And when it is in closed state, the behavior of the object, of the pen object, is not to write. That means when the cap is closed of the pen cannot be used to write. That means the behavior in the closed state of the pen object is not to write. That means we can obviously conclude that behavior depends upon the state of an object. Similarly, the ink used for writing is an important attribute of the pen. Different colors of the ink characterize different states of the ink. So ink can have different states like blue, black, etc. And how can you identify a pen particularly? The pen can be identified by its make, model, owner, etc. So every pen should have a particular model number which will be unique to that pen. Using that model number, or using the make of the pen or owner of the pen which will be unique to that pen object, we can identify the pen object uniquely. So that number would be the identity of the pen object. So we can say that an object is any abstraction that models a real world entity. The term object is synonymous with instance because of the fact that an object is an instance of a collective class. Objects can be concrete like trees, cars, and buildings, or they can also be abstract like numbers, integrals, symphonies, chemical processes, and diseases. Whether tangible or intangible, the object has state, behavior, and identity. So thus an object can be defined as a well-defined entity with an identity which encapsulates a state and behavior. So next let's move on to the concept of class and methods. We have also described the concept of class in my previous lecture. So now this slide is a recap of the previous lecture which I'll discuss a little bit about class again, and a new concept, that is methods, will be introduced. We know that a class is a set of objects that share a common structure and a common behavior. Classes are the templates or the blueprints from which objects are instantiated. It is an abstract entity that represents the essence of the object. So classes can determine what operations its object can perform. For example, we can say mammal is a class. Objects of this class are whale, man, etc. A class thus captures the structure and behavior of all the related objects. Now here in this example, we can see that there is a class mentioned as dog. That means the class name is dog. The properties or the attributes of the objects of the dog class are breed, size, age, color. That means These properties will be there in all the dog class objects. Every dog class object has a particular breed, a particular size, a particular age, and a particular type of color. That means these are the properties or attributes that can be used to identify each of the dog class object uniquely. These are the data members of the dog class. These data members are used by all the dog class objects so that each of the dog class objects can be identified uniquely. Now let's move on to the lower portion of this image. Here we can see that there are some functions or methods written which are eat, sleep, sit, run. We can say that each of the dog class object will have all these properties that are mentioned here. That means every dog object should have the property eat, it should sleep, it should sit, it should run, and so on. So all the methods that are mentioned here will actually state the behavior of each of the objects of the dog class. How each of the object of the dog class will behave can be identified using these methods. So here we can see that each of the object of the dog class can be able to eat, sleep, sit, run. Now how these methods or functions are written? These methods or functions will actually use these data members in order to operate on these data members, because a particular breed, size, age, and colored dog object will have a particular property of eating habit, sleeping habit, sitting habit, and running habit. That means all these methods that are mentioned here will use these data members in order to state the behavior of each of the dog class objects. So basically this is the dog class name. These are the data members or the properties or attributes which will actually be there in each of the dog class objects, and these are the methods or functions that will operate on these data members, which will actually state the behaviors of each of the dog class objects. That means there will be three parts in a class: a name of the class, the data members of the class, and the methods of the class. A name of the class will actually tell you what the class is actually based on. The data members will actually tell you what are the properties or attributes or characteristics of each of the object of that particular class. And the methods will operate on those data members in order to state what are the behaviors of all the objects of that particular class. Now, class name must be unique. Classes should be named meaningfully in such a way that they expose some of the attributes and operations associated with the class. So these are the characteristics or properties of the object that I have just discussed. So if we consider a dog class, then an object of the dog class should have a particular name which will be treated as the identity of the dog. A particular dog object should have some states or attributes or properties like breed, age, color, etc. And a particular dog object should have some behaviors like barking, sleeping, eating, running, sitting, etc. So an object can be composed of these three characteristics: identity, state, and behaviors. Now come to the categorization of class. A class can be of three types: concrete class, abstract class, and meta class. A concrete class is a class of which you can create an object. That means a concrete class can be instantiated. An abstract class is a class which cannot be instantiated. That means you cannot create an object of an abstract class. But you can still inherit the abstract class, and its subclasses or child classes can be instantiated. The last one is meta class. A meta class is a class whose instances are themselves classes. So these are the categorization of class: concrete class, abstract class, and meta class. When we will go deep into the Java programming language, we will implement each of these with examples. So now let's come to the difference between procedural programming language and object-oriented programming language. We have all learned C language, so we know what is a procedural programming language. Procedural programming language is a language which deals with procedures. Now, what is the meaning of procedures? Procedures are basically functions. So procedural programming language or procedure-oriented language, they deal with functions or procedures. That's why they are known as procedure oriented programming or procedural programming language. Now let's discuss the difference between the two language or two programming techniques. We know that in procedure oriented programming, which is also known as POP, the program is divided into small parts called functions or procedures. That's why the name procedure oriented programming. And in object-oriented programming, the program is divided into parts which are known as objects. That means a big program is divided into small parts or objects. So this is one of the main difference between the both the languages or both the programming techniques. The next one is importance. This is one of the most important difference between these two, that in case of POP, importance is not given to the data but to the functions or procedures as well as the sequence of actions to be done. But in case of object-oriented programming language, importance is given to the data rather than the procedures or functions, because it works as a real world. Because we know that in real world we deal with data. Data means input data and output data. What we are giving as input and what we are getting as output will all be considered as data. So what input data we are giving, and accordingly what output data we are getting, whether we are getting the desired output data by giving a particular set of input data or not, that is the real uh, thing that should be considered in real world if we are dealing with real world. And as object oriented programming language is built around real world objects, so data is given more priority rather than procedures or functions, as opposed to pop or procedure oriented programming. The next one is POP follows top-down approach, whereas OOP follows bottom-up approach. Now, what is the difference between top-down approach and bottom-up approach? In case of top-down approach, we focus on breaking up the problem into smaller parts. But in case of bottom-up approach, we first solve the smaller problems and then integrate it as a whole and complete the solution. The top-down approaches are mainly used by structured programming language like C, Fortran, COBOL, etc. But bottom-up approaches are mainly used by object-oriented programming languages like C++, C Sharp, Java, Python, etc. The last point says that POP does not have any access specifier, but OOP has access specifiers named as public, private, protected, and there is also a default access specifier. So in case of POP, we can say that data can move freely from function to function in the system, whereas in object-oriented programming, objects can move and communicate with each other through member functions. In case of POP, most function uses global data, which can be shared and accessed easily or freely from function to function in the system, because POP does not have any access specifier. But in case of OOP, data cannot move easily from function to function. It can be kept public or private or protected or in default access, so we can control the access of the data, and that can be done using the access specifiers that are there in object oriented programming languages. So that's why we can say that POP is less secure compared to OOP, because POP does not have any proper way of hiding data, but OOP has a proper way of hiding data by using access specifiers. That means object oriented programming languages give more security. In case of POP, overloading is not possible, but in case of object-oriented programming, overloading is possible by using function or method overloading and operator overloading. Some procedure-oriented programming languages are C, Visual Basic, Fortran, Pascal, etc. And some object-oriented programming languages are C++, Java, VB.NET, C#, .NET, Python, etc. Now let's move on to the last topic of today's lecture. What is the difference between C, C++, and Java? So we have to know the exact differences between these three languages. So firstly, C is a procedural programming language, whereas C++ is a mix-up of procedural and object-oriented programming language. And Java is a completely object-oriented programming language. In case of C, it is executable in native code or .exe file. In case of C++, it is executable in native code or .exe file, same as C language. In case of Java language, it is compiled into Java bytecode, which is stored in a .class file. Now, what is bytecode and how .class files are created, that I'll discuss in later lectures. C language is platform dependent. C++ is also platform dependent, whereas Java language is platform independent. Now, what makes Java platform independent, that also I'll discuss in the next lectures. In case of C language, if we allocate some memory, that memory has to be deallocated manually using free function. In case of C++ language, the memory deallocation has to be done manually, same as C language, but using the concept of destructor. But in case of Java language, if a memory has been allocated, that memory can be deallocated automatically, which is done by the Java runtime system. That also we will discuss in Java's garbage collection techniques later. C and C++, both the languages use pointers, the concept of pointers, but in case of C++, there are some form of references available also. But in case of Java, there is no pointers, only some references are used. This is a very important concept related to Java. In case of C and C++ languages, both the languages use global variables, but Java doesn't use any global variables. C and C++, both the languages use goto statements, whereas Java doesn't use the goto statement. C and C++, C++ and Java, both the languages use exception handling mechanism, whereas C language doesn't have any exception handling mechanism. In case of header files, we know that C and C++, both the languages support header files, but in case of Java, no header files are supported. Instead, Java uses packages which can be imported. In case of C language, it supports 32 keywords. C++ language supports 63 keywords, and Java language supports 50 defined keywords. Inheritance is not supported in Java. C++ language supports inheritance, and Java language supports inheritance except one, which is known as multiple inheritance. So these are the basic differences between C, C++, and Java. So thank you for listening to today's lecture. See you in the next lecture.